Thank you everyone for joining today. This is the Julia meetup, the Julia user group Munich. Today we are going into some dashboarding skills, and I'm very, very glad we have two presenters with us. Adrian Salceanu and Helmut Haensel is joining us. They are both the maintainers and main contributors of Stipple, which together with Genie is kind of a framework, or one framework, the go-to framework, I think, for building very full-fledged reactive dashboards in Julia. This is the topic for today. Helmut is going to start. He is giving us an introduction to the API, to the main API of Stipple, giving us the basics kind of how to do it ourselves. And then Adrian is continuing with a bit more deep dive into plugin system, how to extend this dashboarding utility to fit your own needs, and also to use other plugins from other people. So really making it a community effort. Thank you both for joining today. I think I'll give directly to you, Helmut. Please introduce yourself also. Stage is yours.
Thank you, Stefan. It's really nice to be here. Thank you, Stefan, for providing this platform to introduce Stipple to this Julia Munich community. I myself, I'm a physicist by education. I work for Merck for more than 10 years now. Merck is a company doing many things, pharma, chemicals, but also liquid crystals. I used to work for liquid crystals for a very long time. I changed position recently and now went in the direction of data science. And that was when I was looking for a dashboard possibility for Julia, because I had written some Julia code and wanted to give that to our internal customers, but without providing the code. And then I saw this contribution in the JuliaCon 2020 by Adrian and said, that's perfect. Still missing some things for my purpose. And I was, I had freedom to add this on my position that I had at that time. So I added bit by bit to the Stipple project, which I find a very magnificent piece of code that Adrian provided there. Really a one-man show with this big genie background and then the Stipple on top. So
maybe before going into the first part of the talk, Adrian, would you like to introduce yourself as well, just for the introduction round?
Hi, sure. Good evening, everybody. I'm Adrian. I'm a software developer. I've been developing software for the web for about 20 years now. I'm a computer scientist. I've also been leading development teams for various startups in the last 10 years or so. And some 6 years ago, I discovered Julia. Basically, we were having some problems on our backend with one of the projects that we're working on. And I started to look. I had experience with PHP and with Ruby on Rails, and at that point, I started to look for some programming language that would be as easy to use as Ruby and the framework like Rails, but that would have high performance. So I tried a few, and then I discovered Julia, which was very new at that point. The language was great. It seemed like a very good option, but it was very new and very young, so that there wasn't any kind of web framework back then. So that's when I started to work on Genie, and Genie grew. Lots of people contributed, and we got a lot of great input from the community. So it's now it's quite mature. But then, at some point, while being at the JuliaCon with the Genie presentation, people in the Julia community started to say that it would be really interesting if there would be some sort of low-code, no-code alternative to easily build and develop and deploy data dashboards with Julia. And that's how the idea of Stipple came up. I began working on it over a year ago. And then, yeah, had the prototype in the summer at JuliaCon. And then, yeah, Helmut has joined the project and then the offer, and he contributed a lot of awesome code. Yeah, it's been growing since. People started to use it, and the library is maturing, and we're now approaching.
So
Hello. Yeah, so that's it. You know, Helmut is going to show the core of Stipple, and after him, I will go into some of the higher level libraries and just see how we can build yeah, a more complex data dashboard with it.
Thank you so much.
Thank you.
So let's dive in.
So let's dive in. So I need some space, my little dear. So I'll share my screen. And I'll start with, oh, I have too much on my screen here. Let me move that away. I hope you can see that. Do you see this lower part of the stipple? Yeah.
Yes, yes.
I'd like to, can we make this lower? Yeah, okay. So this part is on the basics. It's rather on code than on nice looking dashboards, because that will be part 2. It is on the understanding of Stipple, how the machinery works a bit. Although it's low code, I think you have to have some knowledge. And I would just want to prepare one slide, show you one slide. Julia is now the back end. And of course, we have to somehow manage the front end. And in the back end, there's Julia running, but on the front end, there's no Julia. At least I don't know any Julia working in the browser yet. So we have to manage JavaScript. And in order to do so, we have Stipple on the Julia side, and Adrian chose the Vue.js to do all the handling of variables and communication and listeners. So this is full-fledged web framework. To go one level lower, we have models that are part of the type reactive model. The name tells what it is. It's a type that manages all the reactivity on the backend side. And there's the front end side, which has then the view elements with all their fields. There are fields in the model of the Julia variable, and there are fields of the view element, and they have all their listeners that can do the communication between front end and backend. And there'll be part 2 on the Stipple UI and the other extensions of Stipple. And this relies on another sub framework of the Vue.js, which is called Quasar, which has a very nice graphical user interface. And you would see this in the second part. So after having said this, let's go back to coding. So coding is
Let
very...
me quickly jump in just for the synchronization. Everyone, please feel welcome to ask some questions in the chat. So we are even 3 hosts today. So we have quite some possibility to answer your questions also meanwhile, or if we can't answer them, raise them also to the speaker. Please use the chat and the question answering version. And Helmut, depends on you whether people can also just jump in and ask right away.
Absolutely, because documentation is still an issue in this thing. We heard and read this very often. And so if you have problems understanding something, please jump in, just ask a question. We're not so many people. I think we can manage.
Perfect.
Yeah, you're welcome.
Thanks so much.
So writing code with Stipple is easy. Using Stipple, every Julian knows how to start a package. There were 2 imports that I recommend, but it's not mandatory. opt creates a dictionary of symbol any, and this is the type. We could quickly have a look at of what that is. Sorry, there's a dictionary from symbol to any, and if you want to create a dictionary, you can do this with keywords. Hello world would generate something like this, a dictionary with hello to world. This is quite convenient, but it's not necessary to have it, to use it. So now a model that you're using in Julia, we have chosen to have a type that contains all the data that belongs to a model. And normally you would define this with base, keyword def, mutable struct as a subtype of reactive model, and then you put all the variables, their types, and their initial value in here. And but if you do this, you cannot redefine your code. You will always get an error. Not possible to redefine the constant. And so I have developed a version that can be redefined for the time of developing the model. So if you put the stipple here and not the base, you can redefine your example. And only if you go from the development version, set your code to final production mode, then this will also create true structs. They're always true structs, but they get another name. It's some mechanics behind. I don't talk about this today, but it's convenient. So I recommend to use that. Once you have done this, the next step is to initialize the model. That will then pass all these values that are given here to these strings. I do this now, and you see the answer is here, and it has all these types of variables. And now, normally you would perhaps expect something like s : string. And now you have this R in front of this. The R is an abbreviation for the reactive type that we have introduced in Stipple. So that's the reactive. And if I type R, this is nothing else than reactive. So it's just an abbreviation, but it makes text a bit shorter. What is this reactive type? This reactive type is mainly a wrapper on the observable. And I'm not sure how familiar you are with observables. Observables is a package that gives you the possibility of wrapping something around any type, any Julian type, but you can then attach methods to it that are called as soon as you change the value. So that's the package. And if you have any variable, and this is how you instantiate such a variable, that will go that way. Then you have the observable. You could also say, okay, let me have my O like that. And if you want to know the content of the variable, you place these get index brackets around it, and then you have the content. You can assign a value to that this very same way as normal variables, except that you have to place these brackets. If you don't place the brackets, then you get the whole variable, and of course you would override your variable if you do O = 9. So the same mechanics is then true for the reactive type. It works just the same way. It's just called reactive because it has some more properties than the observables, and you will know later what that is. For some time, the previous version that we had only observables. It was just a constant set to observable, but now we have some more properties. So let me go on with the code here. Let me first create a user interface. A user interface is a function that's called when the page is called from the browser. So this is a function that gives you nothing else than HTML text, and that is then delivered to the browser. So let me quickly go through the code here. It creates a page. And if you want to know what a page does, you can easily call this here. Oh yeah, you have to give it some text probably. And that's how you can always try to understand how this all works. You can call these little pieces of code just with some text, and you see it gives you the basics of an HTML page. With some more things, it's all this JavaScript that you need to do all the communication with Stipple. So that's what a page does. Then you have to give a name of the model. You very often give the model name itself, and VM does nothing else. It comes from the view model. It comes from the JavaScript world. So here I said my type is called example, and if I call VM example, oh sorry, VM model, then you will see example. But you could give another name if you want. Some more information. That's a container. It's title of a page. Then you can write text, and this is very similar to what you would write in HTML text. It's a header of the level 1, H1, hello world, then a paragraph. I'm the first paragraph, and I bring you and another paragraph, which then already contains the first part of text. And how you write text that you bind to your model, that's the way to do it. Pass the text macro and then the symbol of the name of the variable that contains the property that you want to bring in here. So I do that now. I tell the program to, if you call the root, to call the function UI. So I call the function as soon as and I open the browser. It opens new window and says hello world. So it's right here. I'm the first paragraph, and I bring you, and you see the variable or the field S contain the triple dots. And if I change this now to Stipple, I bring you not fire but Stipple. So that's it communicates directly. And I told you already, if I have this reactive variable and have these brackets and I assign a new name, I have possibility of linking routines, functions to it that are triggered. And this is done automatically in the background, because when you do this initialize, here all the listeners are already set up to push the content of your model to the connected web page. So the magic is already done. And you can look here, on the other side, how that looks in the console. Here, I type in example because we call that example. You remember this VM model had as result example. This is why it's called example here. And this is now the view instance in the browser. And if I make this open, it contains many things. This is all the magic that the Vue.js brings to it. But then you also see the A, the N, and the S properties, which I had defined here. So that's the only thing we defined. On the Julia side, the magic is hidden in the reactive model type, and it's not visible here. But here on the JS side, you see all these, complicated stuff, I'd say. So that was the first Julia dashboard. It's not so difficult. And it's, quite easy readable, I'd say. Let's push it a bit further, starting with the same things, but adding then more text. For example, here, the next number, it's the same mechanics here, just that I add some more text here. And if I want to then add this element N, I need to put a span element here that contains the variable. And in the same manner, I also put an array here. Remember that we had defined S as the 3 dots, N as 1, and an array 3 to 1. So let us execute this here. I replaced the routine. So now the web page should have changed, but I have not indicated that the web page has changed. But if I reload it, I have a new web page. I have not modified the word here. So the content of S is still Stipple. Here we have our first number and our first array 3 to 1. If we want to make a countdown, then we can do this by just counting the numbers from 10 to 0 down. And you see this is directly translated here. Sleep 1, this is in seconds, not in milliseconds. That will be different in JS. And if you want to modify an array, this is just the same way. Again, the brackets here, and if I execute this here, I have the new array 13579. So let's try what happens if I change an element of this array. I execute this here. Yeah, it's fine, but here's a 10 and nothing changed here. And this is something that might sound a bit strange. Why isn't there any magic that makes me, that notifies directly the browser? This is because in Julia, you have these arrays always as kind of pointers to these arrays. And if you change an element, pointer itself is not modified, so it doesn't know. It should say, hello, I changed. But we introduced a new way of getting around this problem. If I don't have these double brackets, but only have the brackets for the index, then it is indeed notifying. And if I execute this, immediately I have the 11 here sent to the page. So direct indexing on the reactive type is notifying and will send the full array over to the browser and will be decoded here and changed directly. So let's have a look how that looks on the JavaScript side. Again, we can have the example and we have a look at how our array looks like. It's 1, 11, 5. So, and there's the observer connected. That's the listener that does the magic. And if I change something, sends things back. I could also have a new array here and say 1, 2, 3, or 4. Let's see whether we have this change here. So yeah, it arrived. We didn't do anything. We just entered it here and it realized 1, 2, 4. Let's have a look at what's the first element of A? 2. Oh, why 2? Yeah, just remember JavaScript is 0-based and all Julians know Julia's 1-based. So we have always a difference in indexing. So this is not the first element, it's the second element, and it's 2. Yeah, second element gets out, and now we can change it to another value. Let's have a look whether this changed. No, it didn't, because it has the same problems. If you change the element of an array, it's not notified. There's some mechanics in Vue.js that does this kind of update, but if you do it manually, it doesn't. But also here's the way around. If you really should ever need it, because it has an observer, you could do this notify, and then, oh, what did I do wrong? I tried it before, should work. It's undefined. Ah, that's strange. Let me try it if I don't. That should work. I can't tell. It doesn't work. It worked when I tried it first. I try to find the answer later. If I don't, yeah, I'm a bit surprised. Just. Oh, I didn't change the array. That's the point. That's strange. If anyone sees what's going wrong, then I'd be happy. That's really strange. I can't change the array. I think I know what I did wrong. But let's go on here. It's not so important at this point. Let's go one thing more. Sometimes it's interesting to have an array defined and have the elements, only single elements of these arrays indicated. This is possible if you just call bind the array element. It's a bit different. You cannot write this nice symbol notation that I had introduced for the previous examples, but you have to put this kind of syntax here. It looks a bit strange. What is this R? It's a string macro. So if you put anything here, any text, it will wrap it in a symbol and will make just a colon text out of it. And even if there are some characters that are not so easy for Julia in variable names, it wraps the symbol around it. So it binds the symbol with that name to it. Here's some magic. I delete this once just to explain what happens if we do it. Let's get back to this page and reload it. So here I have an array, and now I have placed some input here. And here I have the, binded the text. Let's modify the text. And if I modify the text, you see immediately that here is reflected the change in the elements. And it should also be reflected here. It's now Stipple, and if we would place any other text, then also we have this other text appearing here. So here I've now binded the A1, that is the second element. If I write something else here, it appears here in the array, but it does appear in the quotes, which is not so nice because in most cases I want a number. At least if it was a number before, I can tell the program that please look for a number and not for a string. And that's the mechanics to do it, to have a second argument to the bind macro. And if I recall this and reload this page here. Oh, it doesn't like me today. Should like me now. Yeah, still not. We're having strange things here. Oh, now it works. Yeah, okay. Now it works. I need a
tiny little question, Helmut.
Yeah, sure.
From my side, actually.
Yeah.
This number looks like a type. Is this translated to a JavaScript type, or for instance, could you also enter?
It's a JavaScript type.
Okay, yeah. Could you enter number, like the Julia type for numbers?
No, you have to enter JavaScript type because that's the way how this number is interpreted before you send it back.
Mm-hmm. Understood. Yeah, thanks. It's directly kind of copy paste in there.
Yeah. But if you have a type defined, well, if you have a mixed array, then it's difficult to reattribute the a text to a number because if Julia expects a number, it will not automatically convert a string to a number. There's no automatic type conversion. If there would be, then that could work.
No, but fine. That's perfect to know that it's just JavaScript side.
It's a JavaScript type that you can enter here. Yeah.
Thanks a lot.
Yeah, good question. So let's go on and define some functions. Because I told you this reactive type has the possibility of triggering routines, callback routines, if you like. So let's define it. Ah, that's the point. I have too many callers already in the background. That's strange. I think I need to restart Stipple because I have to. Let's try. Too many listeners hanging around. Sometimes they're not deleted. I'm afraid, Adrian. Have you ever experienced that? I had this already once, that I had loops of.
Have you tried with off, or I mean, were they supposed to be deleted at some point?
Yeah, I thought if you redefine your model, they're all deleted. Shouldn't they be deleted?
I never tried that. That's part of the observables, and we don't have any kind of explicit off, so they might be collecting in memory. We can look into that. I don't think we have.
Perhaps we should define them as weak, that they're not triggered.
Yeah.
Maybe.
Yeah.
So that they're collected by the. Yeah, that's probably the point.
Yeah.
So let me just to not confuse you anymore. I will shortly restart the session to be sure to not have too many routines here traveling around. And we look into this part, Adrian. We should notify our project.
Yeah.
So where were we? Somewhere here, I think. Yeah, and I said let's define a routine that is called as soon as you change a. So that's the syntax of how you attach a routine. Most of you are probably familiar with this DoBlock syntax of Julia. It creates an anonymous function that is then called here or written like a normal function with an end at the end, and it triggers as soon as that part changes. So we'll do what you write, and it will, for example, here call a. So let's see what model is. Model.a. And if we change it now, oh, that's bad because we have not refreshed our screen. We've not. That's something we also need to still do. If the web page has not yet connected, then the mechanics tries to send something to the web page, and it fails, and we need to still catch that error. So it should work now. Yeah, now it works. it tells me A was updated and it tells the value of A. So that's a routine that always runs as soon as you change any value. Sorry for this short interruption here. You can have a second routine running and all the two will run unless you tell them to go off. So let's make another change to A here. And we'll call two routines. A was updated too. Yeah, but where do we write this here? We don't write it as info here, but we wrote it to the content of the string. And this is what happened. So where we had Stipple before, it's now written the text that we had updated by the function. And also here this part then changed to that very value. So that's the way how you can easily change things. If you have some mechanics of a game or of any dashboard, one variable changes, you can say, okay, update my other values. And that would be this part here, where I update the values. Sometimes, however, if you do this, you don't want directly to update your web page. And that's one thing that we recently invented for this. We had this model of A. We could say this is a new array. But if you don't want to call the routines, then you can put an exclamation mark in here. Then you can change the content of your field without updating the web page and without calling all the other routines here. Sometimes this is really nice and just call it at the end, particularly if you have, well, in the array case, of course, you can always change single elements. Then I told you before, this would also be non-notifying, so no routine would be called. But in the case I call it with this syntax, and I call the routines again. So the exclamation mark for me, the way of reminding how it's called is the exclamation mark stands for not notifying, non-notifying, and you can change the content without sending something to the web page, particularly if you're setting up your interface with variables before everything is done. You can use that efficiently. And if you want to notify something, you can use the notify function, which comes from the observable package, and say, okay, just tell, oh, that's still the old syntax. We have not imported that. We should. Yeah. That's the notify function that tells the that this should be resent, and all routines that are attached to it should now be triggered. So that was the overall setup of the, let's say, the first round of the interface, of the reactive interface. Before I move on, I just give you 5 minutes to ask questions if you have any, anything which is unclear. Well, nothing. Very quiet. I see there's a chat. No, that's all fine. So in that case, and there's no questions, I continue. And this is now about the properties that are new to the interface. very often you have a model and you have parts of the model that you don't want to share with your, with the front end, or you don't want that you can change this value by the front end. And this is possible by saying something like public, just separate by a comma after the declaration of the initial value. Just add public to it. Or there's, well, public, you can leave it out. This is the default, but there's also read only and there's private. So let's have a look what that would look like. Let's define this new example. I overwrite this and I have a new model. So if I call my web page now, that should look like this. And let's have a look in the console. Example. And now we see A, D, F, and N, and S. But we don't see the I. So that is, let me just change it, it's easier readable. It's some warning if I redefine the structure. Julia thinks I don't know what I'm doing. So you see this private is completely hidden. It's not transmitted to the front end. And there's a read-only value. Of course, I can change the value here, but it will never be transmitted here. So if I have my model, .n has the value 1. Oh, I thought, yeah, you see this number. It changes, but if I would change the value here, this should not be changed here. And that's how it is. We found this is very, very important. For example, if you think about games, everybody could just change the status of the game and it would be just sent back to the server. So there's, even if you would know the mechanics, how to send a command to change the value, it's then blocked internally. So it really doesn't go back to your model. It's completely restricted. And yeah, private is not visible at all. There's some other things. Sometimes you need functions. It's, of course, only if you work really with high-level applications, but sometimes you do need functions, but they don't travel across the JSON protocol that we have chosen to communicate between backend and front end. And so if you have a value, for example, a dictionary or directly text that contains a function, then you should add the JS function keyword after it. It's a mode, and it tells Stipple that it should look for some function declaration. It analyzes what you have written, and if something is there that looks like a function, it will convert this function to a different representation. It will travel to the JSON backend and will be then decoded here on the front-end side. Let's have a look how that could look like. This is dictionary, only contains hello world in the beginning, but then I define a new field of this dictionary to contain the function return example n plus 1. Let's do that. Let's have a look whether I could use this function here. Example dictionary.f is a function, and it is return example n plus 1. So it has correctly decoded this function. You can also call it, and then it has the value 2 because the value of n was 1. The same is true if you only have a single variable for a function. You should declare it as JSON text. JSON text is a text that's propagated through the JSON protocol without any addition of quotes or so. And there's a short form of it to define such a function. This is JS or JavaScript function. And you could write it that way. That's possible. There are other ways of defining a function. For example, yeah, like a normal JavaScript function like this one. Let me highlight this one. And now let's have a look whether I could successfully change that. Example.f, now function, and yes, it was accepted, and I can call it. It will give me this alert warning, and the value of n is 1. So you can pass functions now with the new Stipple, reactive Stipple. And this is very convenient because sometimes you really need to call something directly on your browser, and you can do that with this way.
And with this one question in the chat.
Yeah.
I am actually not sure whether I understood it correctly. My JavaScript may be limited. Is it possible to give priority functions with observables? There's a bit more to it, but the question is from Pierre Springer.
Yeah, Pierre, please. Then I've also not really understood. I don't know what priority functions are.
I think, well, I'm guessing it is the idea of being able to sort the handlers in the stack. I think it's an interesting idea. That's something that should probably be part of the Observables API. But basically just being able to decide in which order the observables would be invoked rather than the order in which they are being added. So yeah, that's super interesting, but it's I think these handlers are just like an array, so you can't really reference them by any kind of label or tag or anything like that. But yeah, it's definitely an
well, you could probably change the listeners. I don't know how that will work. I mean,
maybe
we could
push them, but yeah, like reference them somehow, maybe push them. Yeah, it would be interesting to have an API for that, for sure.
I think yeah, you can see what the listeners are. Oh, no, it's a. Oh yeah, it's an array, and you don't know whether you can change. You would have to look into the details of the observables package whether you can reorder the functions. I think that
chances are good that will just work if you order them yourself.
Yeah, I'd say so. But I don't know what the garbage collector will do. Maybe Java should work. Probably it works. Is that answered then? With this, let's hope so. So with that, I come to the last possibilities of changing properties. I've not talked about the possibility of directly binding or integrating fields without the reactive type, which is possible and can be useful from time to time. If you don't want to change a variable, for example, you could use this, but it's still reactive always on the front end side. So let's have a look at this definition here. Just yeah. This defines it the very same way as we had it previously with the R, just leaves out the R. It will not automatically be, if you change the value, not transmitted because there's no possibility of knowing when this is changed. But you can always do that by hand. So if you have defined your, sorry for that jump, if you have defined it that way, you can call the push function of the model And then you have to tell you want to change the field S to a new value. And that should be it. So yeah, you see it changed. That's the intrinsic way. So if you want to care for pushing the values yourself, you can do it that way. The way back is possible. So if I delete that here and ask for the value here, model.s. Oh, I didn't initialize it. I'm sorry. I should. So let's reload the page. We don't have the correct UI for that. That's why is that? I didn't test this part of the code because I didn't want to demonstrate it. That's a bit strange. I make this later. I show this later to you if you want to see it. Just no, I just need to talk im Trockenen. So without demo. Yeah, again. So it will propagate back directly if you set this value in your with your app here, and you can read it here in Stipple. If you add an underscore to the variable, this declares this to be read-only, and if you add 2 underscores, it will be private. That's a standard. You can change this. There are, if you look into it, patterns that define the read-only and the private properties, but that's the standard definition. And this is true not only for the intrinsic types, it's also true for the reactive types. If you don't add anything with a comma, you can always overwrite it here if you want to have this read-only, although the underscores would indicate it is private, you can always overwrite this. So this has priority over the pattern matching. And gives you some more possibilities. Particularly, it's meant for the fields that are not reactive, because you don't have any possibility of telling otherwise whether they should be read-only or even private. So I hope that this gave more clarity to the interface of how you can define your core of your application and how to design your variables and what you can, how you can hide things, how you can make things read-only, and how you transmit your data from one side to the other. Mostly it's invisible. Only if you want, you can do it manually. And I hope that Adrian can give more visible style to what we learned now.
Sure. Thank you, Helmut. This was super amazing. It's like these are super new. I haven't seen many of those things yet. So that's brand new and super amazing. That's yeah, those are awesome features. Thanks so much. Well, you've made my well, things much easier for me now with the intro. I'll just take it from here. I don't know if anybody has any questions, maybe at this point.
There's one question From Julian Vasil. Is it possible to submit get post requests directly from Stipple? So
Yeah.
I'm not sure whether I understand the question. Probably refers to standard HTTPS communication.
Yes, yes, it's possible to do that. You do that via the root command.
Yeah, so if I may give some details on this one, is basically, per the diagram in a sense. So Stipple is designed for communication over WebSockets. So it's changing state and synchronizing state between backend and front end without page reload. Well, it's possible to do get and post requests. So if you do it by default, you can just drop a form, submit it, and then have another page being loaded, define a different route, and process the payload. Or you can use a bit of JavaScript, for example, to make an AJAX request, and then just receive it in the other in the other route in the backend. But that would be more about I don't know, lower level web development, and not. I mean, the Stipple way would be to just synchronize state between backend and front end. But yeah, it's definitely possible to just use a standard form, submit it, and then receive the payload on the server side, either doing a full page reload or using AJAX for that. Does it answer the question? Does it make sense? Cool. Okay. I had a couple of questions, Helmut, if I may.
Yeah.
In regards to the functions, that's like super interesting. I don't know, would you be able to share the screen again and look at the example a little bit, or?
Yeah, sure. So I reshare.
To understand some of the options there.
Yeah, here we are again.
Yeah.
Now you see something that you shouldn't see, probably. That's the way. Yeah, that's what you should see.
All right. Can you, okay. Yeah, for example, yeah, that where you were. So the opt hello world, how does it work? Like, what's the role of that?
Well, that was just to define a dictionary that has some content, but no function yet.
Okay, so that's basically a reactive dict, which has.
That's a reactive dict which contains anything, but it can also contain JS functions. And if I transmit it, it will scan the full dictionary to see whether there's any content that looks like a function.
Okay, so when you do these opts, it basically it puts a value in the dictionary, like key hello and
key hello and value world.
Okay, and then the function, how is it being added? Like
so yeah, shall we have a look at the web page perhaps again? So the function is added here. Let me go to this part perhaps. So model.d is the dictionary, and I didn't talk about it. We have the same syntax here. If you want to index a dictionary, you can do that with leaving out these double brackets because you want to also notify. So this is the notifying call of adding an element to the dictionary, which is called f for function. So after that, the dictionary will contain the value f. Let's have a look at model.d. It contains hello world, and it contains the new field function f, which is then JSON text of function.
Yeah. Okay.
But this will not be, this will be transmitted via JSON, it will not accept this. The JSON text will not be returned as a function, it will be returned as a string. So during the push command, it realizes this is the this is the function. It will code this in a different type, in a sub-dictionary, if you like, with body and argument. And on the front end side, there's the reviver that looks through the dictionary and looks for exactly that type of dictionary, and will then convert this to a function, which lives at the level of your view element.
Oh, it's pretty cool. Yeah, super amazing. And in line 190, I see this is like an uppercase function. Is that like the function constructor or what?
No, the uppercase is because it's a constant.
Oh, okay. A constant.
It's just a numeric constant.
Okay.
JS function is probably 4 or 8 or something.
No, not JS function. If you go to the left, the function is uppercased.
Oh yeah, because that's a JavaScript command to construct a function.
Okay, so it's the function constructor basically. We could
it's
also
the function constructor. It's JavaScript syntax.
And that takes,
it's different to the eval, because eval has different. I don't know so much about the levels of security, but it's a bit more secure because it's not allowed to go anywhere other than eval.
Yeah. That's pretty cool.
So I use this function constructor.
Got it. Understood. Yeah, that's awesome. Super cool. Okay.
But you could also write a Java function, not in this. You could also write a function with this syntax here, which would be the standard syntax. But we need to talk about this a bit, or I need to modify it, because if you load these things, they have a different range and they don't find the properties here with this. If you reload the page after having set this, they only can. Yeah, it's perhaps too detailed for this talk here.
Yeah. It's probably some scope.
They have a different scope. If you define a function like this, and if you define a function like this, they have different scopes.
All right. That's.
But if you transmit it via the back and front end, so dynamically, it will transmit something different. It will transmit this type internally. You don't see it, but it will transmit this type. But if you reload your page, then and don't call an update of the field dynamic update, then it would have this old value, and that's all fine, except if you want to address fields of your model, this will not work, and then you would need this type of function declaration.
I see.
That's a bit internal stuff. Most Julia users don't want to know about these things, probably.
Yeah. Interesting. All right, that answers it for me. I don't know if anybody has any other questions, so if not, we can.
So one short one. If you want to dynamically define some variables, then you would actually use this dictionary style, or so there you can also add new variables from the JavaScript.
Exactly.
side.
Yeah. If you need dynamic variables, you do this with dictionaries, and they can contain anything, even functions. But currently, the function type dictionaries don't support transmission to the backend, because how to transmit a function, you would need to write another communication thing, which I have not done yet.
Yeah. All right. So then basically, if new elements are being added to the dictionary, to the reactive dictionary, they are being pushed to the front end.
Yeah.
Nice. Yeah, I don't see a lot of use cases where you would want to like push back functions from the front end onto the back end. That's probably dangerous anyway, I think so. But from here to the front end makes a lot of sense.
Yeah, exactly. This is why I chose just to have functions going in one direction. They're always read only automatically.
Wow, awesome.
All right.
Okay. Then I'll take the screen. Okay, Helmut, if you can please stop sharing.
Yep.
Thank you. All right. Okie dokie. Okay.
And Helmut, if you can share the code you
Yeah,
use
I
today,
will.
that would be awesome. Thanks a lot.
Sure.
All right. So Helmut has already gone over this. I'm just going to just yeah, go over it.
We had the same ideas.
Yeah, exactly. Just slightly different. But yeah, basically we have the backend side and the front end side of things, and Stipple takes care of synchronizing automatically the data between backend and front end. The really good part is that Stipple uses this kind of modular approach where we have different layers of applications, and we are able to deploy pretty much all of the Julia's package ecosystem and all of the available libraries to build really powerful applications and data dashboards. So for example, at the bottom, if we start with the lower level where we have Julia, here in Julia, we can use the package ecosystem to basically add any kind of packages that we want to our applications. And as we'll see in the example, for example, I will be using the clustering package. But yeah, we can add any other packages, and we can run any kind of code that we want on the server side. This is just Julia in the end. And also at this bottom layer, Julia and the HTTP.jl package it is what takes care of data transport. So if this is the lower level layer where data is being sent between backend and front end using by default WebSockets. But also an important point, some web hosts like Julia Hub, for example, do not allow WebSockets. So then we have added support so that optionally the data can be synchronized by push and pull. So over HTTP, over AJAX, if your host does not provide WebSocket support, you can switch, and Stipple will automatically push and pull and synchronize over HTTP. Then on top of Julia, we have Genie and its package ecosystem. And Genie is the lower level web framework which generates HTML, CSS, and JavaScript and handles all the lower level elements of the stack. Again, here in Genie, we can use all the available packages. So for example, we can interact with databases, we can use caching, we can use configurations, we can use all of the things which are available in Genie. On top of Genie, then we have Stipple, which runs on top of Genie and takes care of or uses the lower level features available in Genie. And Stipple's function is to pretty much synchronize the data between Julia models, Julia types, and Vue model or JavaScript types. And this is what Helmut has been presenting us. This is the level of I don't know, automatic data sync between backend and front end and backend. That's the core functionality. That's what provides connectivity between server and browser. And now, if we want to build more complex applications, we take the same modular approach, and we come up with additional packages in the form of Stipple plugins. These have Stipple as dependencies, so they run on Stipple and provide specific and more advanced functionality. The ecosystem is growing with a series of packages to address various needs. Some of the most important ones at this point being Stipple UI, which contains a lot of user interface elements for building web applications. Stipple charts, which is a plotting or charting library for Stipple. Plotly, which is an alternative one, a newer edition, which uses the famous Plotly library for charting. Stipple LaTeX, which is used for rendering LaTeX on web pages, like reactive LaTeX content. And these ones, so Stipple plugins basically map onto JavaScript libraries, which are implemented on the front end as Vue.js plugins. So UI actually wraps around the Quasar Vue or JavaScript library. Stipple charts uses Apex charts, and Stipple Plotly uses the Plotly JS library. So then our applications are basically the red blocks, the ones which are at the top of the stack. We write our code here on the backend in the red area is the application, the server-side app. And we basically can take advantage of all the stack that is under us. So we can deploy and use the APIs in the Stipple plugins. We can use the Stipple core. We can use the Genie and its ecosystem. And we can use Julia and all its package ecosystem as well. And automatically is going to generate the rich, powerful applications on the client side. As such, in terms of data exchanges, then we have on the back end the Stipple model, which is what Helmut had shown. And within the model, we can define the data types which correspond to our plugins. So, for example, the UI plugin comes with its types. Charts come as well with these types. Plotly comes with these types, and they are going to generate the corresponding properties in the Vue.js model. This is an example from the application that we will see today. So, for example, on the backend, we can see how the Stipple model is the one that wraps the whole data, all the fields, and how they are being outputted into JavaScript. How the JavaScript, the Vue model, is being generated automatically. So, for example, we can see that our model, Iris model, creates a new JavaScript object, which is called Iris model as well. Then the same name is being used to reference the element in the page where the application is going to be rendered. And then we can see how the various fields on the server side are being mapped to their corresponding fields on the client side. So, for example, the credit data pagination field, which is of type data table pagination, is going to get its own JavaScript representation as expected by Quasar, by the UI element. Or, for example, we can see the features field, which is a vector of string, which is here with the purple box, and which is rendered as a JavaScript array. Or the clustering features as well, which is representing as a different array. There's a very simple API to convert fields from Julia to JavaScript. Basically, we need to specialize a Stipple render method for our types. So, for example, we have a Stipple render for data table pagination, which will construct the corresponding JavaScript dictionary. And in the other way, in order to send data from the front end to the back end, we need to define a base parse, which converts from a JavaScript dict back to our data table pagination object. And then from the same code through Vue, we can recognize the various data fields and the various data types as rendered on the user interface. So, for example, the number of clusters field is used here as the data binding behind this slider for the number of clusters, or the X features are going to be used here in the box for the X features, or the Iris data, which is of type data table, is being used in order to populate this table of data. And again, we can see that the data table pagination is being used in order to render the pagination component of the data table on the client side. Any questions so far? Okay, I will take it that no. All right, so then Stipple plugins are very light Julia wrappers around Vue.js plugins. It's very easy to create Stipple plugins. It takes really minimum boilerplate code. We just need to set them up as Julia packages. So we're going to need a project toml file. We're going to need to define the main module in the source folder. And as mentioned, we would need to specialize the Stipple render method for the types defined by our package, and optionally a base parse for our types if we want to accept data updates from the front end towards the back end. The really good part of this approach is that basically any Vue plugin or library can be converted to a Stipple plugin. But it's worth mentioning that at this point, Vue version 3 has come out. So the whole Vue ecosystem is migrating from version 2 to version 3. Stipple is currently supporting version 2, but will add support for version 3 soon. But that's pretty much more of an implementation detail, as the Stipple API will remain consistent. Another good thing is that pretty much all mainstream JavaScript libraries now support Vue alongside React and Angular. So then we can expect that if there are any kind of user interface element or libraries that we would need to support in Stipple, we can add it. And if that library does not support Vue, which is very rare these days, again, it's relatively easy to convert any kind of JavaScript library into a Vue plugin and then bring it into the Stipple ecosystem. So that in theory, we can port any kind of JavaScript library to Stipple, thus allowing us to create a really wide and a really rich ecosystem with all possible user interface elements and functionalities, everything that is present now in the JavaScript ecosystem. Okay, so then at this point in the plugins ecosystem, we have Stipple UI, Stipple Charts, Stipple Plotly, Stipple LaTeX, and Stipple Plotly Export. And I'm going to go over them very quickly. Stipple UI, there's the link to the repo if you want to take a look. It uses Quasar, which is one of the best UI libraries for Vue. It has a huge number of elements. We haven't gotten to the point to implement and support all of them in Stipple yet. But for example, there are elements for forms, so like text inputs, dropdowns, radios, checkboxes, toggles, range, sliders, buttons, and a few others. The ones in green are already implemented. Then we have for data rendering and collections, we have the data tables, lists, and the timeline. And there's a lot more others like badge, banners, card, chips, dialogues, avatars, breadcrumbs, and basically whatever is needed to create a modern cross-platform application. It is available in Quasar, and it can be made available in Stipple if it's not already implemented. The plan is to add support for all the Quasar elements before Stipple v1 is being released. However, there is also the QLM API, which allows adding elements like simple elements on the fly, so elements that don't have a very complicated API. Helmut implemented this, so yeah, maybe he can give us more details at some point. But basically, it allows us to bring Quasar elements into our application, even if we're not explicitly supporting them. These are some examples of UI elements from Stipple UI and from Quasar. So we see, for example, some badges. We have a card. We have banners. We have form elements. This is a data table, color picker, all sorts of buttons and themes. And there's a lot more. You can take a look at the Quasar documentation, and hopefully soon Stipple will also have its own documentations with examples, and you'll be able to see them there as well. Moving on, Stipple charts. This uses Apex charts, which is a great charting library, which comes with official Vue support out of the box. The great advantage of Apex charts is that it is highly customizable in terms of look and feel. So it can easily be themed. It looks very nice. It looks very clean, very polished. It does include a wide range of basic and not so basic charts like line, area, column, bar, and many others. Most of these types of charts are already available in the Stipple API, and the few remaining ones will also be added before version 1. This is what they look like. So they're very polished. They look really well, and they provide a lot of flexibility in terms of theming and designing the charts. Then we have Stipple Plotly, which is based on Plotly, which is one of the best known and widely used plotting libraries, and it's also kind of the default in the Julia ecosystem. The advantage of Plotly is that it covers a huge amount of types of charts, so pretty much any kind of plotting needs there's going to be a Plotly solution for it. The downside being that it's not as easy to customize as Apex charts. So depending on your need, you may choose one charting library or the other. Again, most of the API is already implemented in Stipple, and the remaining types of charts which are not already covered will be added before version 1. With Stipple Plotly, there is an additional plugin which is called Stipple Plotly Export, which adds an extra API to Stipple Plotly so that you can export the rendered plots as images or as PDFs or whatever, as static files, let's say, from in a programmatic manner if you need to generate charts on the server. And more recently, we've seen some early community experiments where users have been combining Stipple Plotly with Plotly.js.jl. And it looks like it's possible to use the Plotly.js.jl API in Stipple with Stipple Plotly, which is a great advantage because it means it makes it really easy to use the Plotly.js.jl API or migrate code that has been already created with Plotly.js.jl. These are some examples of Stipple Plotly charts. Some of them are quite powerful as provided by the Plotly API. So
quick question. That we just saw the 3D plot.
Yeah,
I know from using Plotly in Jupyter notebooks that this is actually, or this can be interactive 3D plots. It's also here, isn't it?
Yes. So all the plots are interactive. Yeah, it's all of the Plotly functionality is then available in Stipple. Although the package is quite young, so it's going to take a bit of more testing and documenting and working on it. But all the functionality which is exposed in the JavaScript libraries in Plotly will be also available in Stipple, and the interactivity. So if you're setting up listeners to basically listen to click events or to updates coming from the user interface, from the front end, they will update the state on the server side. So for example, like zooming in or clicking on various elements of the chart.
Thanks.
You're welcome. Then, Stipple LaTeX, which allows this kind of reactive LaTeX content and the rendering in the Stipple ecosystem. Uses KTeX, which is quite fast and powerful for LaTeX rendering in JavaScript. And that's about it. So just to give you a quick demo of a data dashboard built with Stipple, we'll take a look at the dashboard for iris clustering. I think most of the people will be familiar with it. It's like the hello world of the data science world. But for those that are not familiar, it's basically a data set of 150 observations covering three species of iris flowers, with 50 observations for each species of flower. And this is a very good example in my opinion, because it works with a small data set and it doesn't take a lot of data processing, so we can really focus on building the UI and the interactivity. So we're going to create a dashboard that will allow us to perform clustering and display the clusters onto our data dashboard and interact with it in order to tweak the parameters of the clustering. So these are, just going into a bit of more details about the data set. There are these three types of iris flowers: versicolor, setosa, and virginica. And the idea behind the data set and behind the clustering project is that using the sepal length or the sepal dimension and the petal dimensions, we are able to differentiate between these three types of iris flowers. And yeah, you can see here how the features are present on the flower. We have the petal and we have the sepal, and then we have the length and the width for both of them. And we have these observations as features in our data. Here's a sample of the data set. We have a few columns. We have the sepal length, the sepal width, the petal length, petal width, and then the column for the species. And you can see that the first ones are for setosa and the last ones are for virginica. And in the middle, we would have the ones for versicolor. Okay, that's it. Any questions so far? Okay, no. All right, it's a bit challenging just showing how this can be built, but I thought, there would be multiple approaches. We could, for example, start with the data and build our model representation, then hook it into the front end. But I thought that for demo purposes, maybe it's better to start from the outside in and first take a look at the user interface, have our placeholders, and then progressively add more features and hook the data to the UI. There's one question in the chat. Yeah.
Actually, some minutes ago. Sorry for skipping it so far. It's again by Elian Vasil. Does Stipple support passing cursor information or click info to the backend?
Not at the moment, but it's something that we're working to add. So basically to capture the click events and then update some corresponding variable on the backend. At this moment, we don't have the API implemented for that. Okay.
One further question from my side. So I hope this answers the question. My question would be, in the Julia ecosystem, there's also the Vega, or I'm not sure what to pronounce it right, the Vega plotting ecosystem, which also has JavaScript implementations. Have you some plans about also supporting this?
I haven't looked at it.
So Vega Lite, I think, is the.
Okay. Yeah, we'd have to look and see how it works. I really don't know. Is it based on some JavaScript, right? Library, or I see something Vega Lite.
Yes, it's.
It's
just an alternative plotting system. Yeah.
Let's see if, for example, Vega Lite view. If there's any kind, So I see that, for example, there's Vega for Vue.js. So then, based on this, we can implement like this thin layer of Julia around it, and we can expose it as a Julia package in the Stipple ecosystem. So it's possible. It's definitely doable. Because I see there already a Vue plugin for it.
Thanks.
You're welcome. Okay, I'm gonna start by showing the full demo, the full application, just to give you an idea of what it's going to look like, and then just go through a couple of steps of building it. Let's see. Okay, let's do something while waiting. bit slow. Must be the video using the processor. All right. So we compile the application and starting the server, and it's opening the browser on a random port. Loading. Okay. All right. Yeah, first run is a bit slow now. I think video streaming is eating a lot of resources. But basically, this is what we're going to build. So we have a couple of inputs here at the top. Here we can select the number of clusters that we want to generate from our clustering algorithm. How many iterations the algorithm should go. The more iterations, the better will be the clustering. Then we're going to choose the features that we want to use for the clustering. For example, we can choose petal length and petal width. And once we set up the features to be used for clustering, this is going to trigger the clustering package, the clustering library, and is going to create and render the clusters. It should be working now, but it's a bit slow. All right, so we can see now that it has computed the clustering. And then here in the middle, we're going to have two plots. One of the original clusters is defined by our data. Using the information that we have in our data frame. And these are going to be the clusters as computed by the clustering package. We're going to render the two plots. And then here at the bottom, we're going to have a data table which lists the whole data. And this one allows us to actually interact with. We can look at the data there. We can use the pagination to go over it, or we can decide that we want to show more. And yeah, this is going to be the data dashboard that we will create. All right. So then we said that the easiest way would be to just start with the user interface. And I'm going to show you what it looks like first. Let's see if this works. Oh no, because I have. Okay, I'm going to stop the initial one and start this again. Okay. So then we start by declaring the packages that we are going to use in order to build our data dashboard. We want to use Stipple, and we want to use the Stipple UI package, which helps us build some of the elements in the page, like the whole layout of the page, the form elements, the drop downs, and the data table. These are elements that come from the Stipple UI package. And we're also going to be using Stipple charts in order to render the two plots here on the page. As Helmut had shown, we define our reactive model. We just call it Iris model, and it's an instance of reactive model. We don't put any properties into it at this point because we just want to set up a simple UI with some placeholders. In the UI function, we use a dashboard. Then we set it up with our model. We pass a CSS function, or a CSS class, which is called container. We give it the title, Iris Flower. Move this. Iris Flowers clustering. And we said that we want to use favicon support, which is going to add this, this favicon here. And then we set up a heading where we say iris data k-means clustering, which is rendered here. And then we define the layout of our page. So we use the row element, which basically creates a series of rows which are stacked one on top of each other. And within each row, we can define cells, which are elements within the row. So then we have 3 rows, and each of the rows has individual cells. On our first row, we have a cell which has a heading with the number of clusters. We have another heading with number of iterations, then the X feature and the Y feature. In the second row, we show the species cluster heading and the k-means clusters. And at the bottom, we set up a placeholder for our iris data data table. And for now, we just put the heading. The really nice thing about using rows and cells is that this lets people handle all the layout. And this makes our layout responsive by behind the scenes using Twitter Bootstrap. So for example, you can see that if I resize the page, pretty much the content of the page will resize. And if we go lower, we're going to hit page breakpoints, which switch our page to support vertical or maybe a mobile layout when the width of the page becomes too small. So then by using Stipple's layout facilities, layout API, we get these responsive layouts out of the box. Okay, here at the bottom, we simply defined the route. We'll say that when a request is made in the root of the application, we want to render the UI function as HTML. And then at the bottom, I'm just starting up the web server on a random port, and I tell it to automatically open the browser. Any questions so far? I think not. Oh, there's something in chat, but I think that the older one, yeah. Okay. So I'm just going to stop this. And we can go into the next step and just start adding our data into our reactive model and also displaying it onto our UI. So just to show you a bit of the diff between the previous version and this one, in this step, we are going to add some of the libraries of the packages from the Julia ecosystem, which provide the clustering functionality and give us access to the data. We're going to be using the clustering package, and we're going to be using our data sets. These are all open source packages. So basically, clustering provides clustering functionality for Julia. Our data sets, if you haven't used it, is very interesting. It gives access to some of the famous sample data sets from R, and of course, the data frames package. Here, we start by setting up our variable which contains the data. We load our data set from the R data sets, and we use the iris one. And when we set up our data reference, we also add an additional feature, an additional column, which is called cluster, and that we fill up with zeros. In the next step, we go on and add the fields for our reactive model. We add the iris data, which is going to reference our data. Then we create an additional one for managing the pagination of the data table. These ones are going to be used to set up the options for the plot. And these are going to be the fields corresponding to plotting the left plot, the iris data one, and the resulting clusters. The next three fields, these one are used for filling up the drop down with features, and we initialize X features and Y features as empty values. Also, for the number of clusters and number of iterations, we set them to 3 and 10 respectively. In the next step, we go ahead and initialize our model. Here, there's an extra step. Some of the packages which require more advanced front-end integration have this kind of component registration step, and Stipple charts needs this in order to load the additional JavaScript files into the front end. In terms of user interface, we simply now hook our data into the UI. So we add the slider element. Actually, let me show it here just so that it's easier. We basically add here the slider for the number of clusters, which is this one. We add the slider for the number of iterations. We add the X feature, this one, the Y feature, the plots, and the data table. I'm just going to run it so we see what it looks like. Now we're going to load the code. Oh, it's evaluating.
Adrian, while we're waiting, could you comment on the syntax of the slider command? I think that's very interesting for the people who have not seen how this is called.
The slider. This one here.
Yeah.
All right.
Particularly the binding, because it's common to any view element that you bind.
Yeah, yeah. Well, let's take a look. I don't remember all the details, but let's see what we have here. So slider is then defined in the range module, and as its argument, it takes this range, which indicate the minimum value, the maximum value, and the step of the slider. Then it takes the field name, so the field that it's going to be binding to. And what else do we have? And then a series of keyword elements where we specify if we're going to show the label for the slider. So yeah, like you said, the slider can be considered in a sense one of the typical Stipple UI elements, in the sense that it takes an initial value, it takes a binding for one of the fields in the reactive model, and then it takes a series of keyword elements which makes the rendering or control the various settings of the UI element.
But the important point to know is that the name that you give, the number of iterations, for example, where you are with the cursor now, is set to be the element of your model that it is linked to. So as soon as you change the slider, this element of your model will change, and the function that you use is the macro data. Yes,
correct. Let me reload this.
Sorry for jumping in here.
No, it's okay. That's a great point. So basically, like you said, well, in this second step, we're simply rendering the UI elements and we're hooking the data in the backend. But well, interacting with the UI at this point would not cause our code to trigger. So there's not going to be any clustering at this point, but we can interact with the elements. And because we already have the data bindings here, we're going to get all the updates coming from the front end. So for example, now we have a number of iterations set to 110. So then if we have iris model number, iris model,
you need the model, not the type.
I see model.
NO.
It's the number, it's no way, yeah, number of iterations. Let's try it again. So yeah, this one has been updated to 110. I think we can just get the value, right? If we do this, yeah, it's going to be 110. And if we change it, yeah, now it's going to be 160. And this goes for all of the elements here. So we can change the selection in X feature and in Y feature. And if we do X, like this, X feature, it's already going to contain the petal length, and so on. The iris data, there's just read-only. So for the table at the bottom, we only display the information that is in there. And this, at this point, is being done on the client side. So all the data is being sent over to the front end, and this kind of interactions, as it is right now, they don't send any updates on the server. This component allows to set up server-side pagination and filtering and sorting when handling large amounts of data, where it wouldn't be feasible to send all the data onto the front end at once. But that's going to require more, let's say, more complex setup, as we need to define dedicated functionality to perform the filtering, the sorting, and all the other operations that we want to do on the data dynamically as the users interact with the front end. Okay. Everything clear up to this point? Is it obvious how it's done? Okay.
I would add another note, Adrian,
yeah,
how you bind the features to the options.
The features to the options.
For example, line 74.
74. Yeah.
So the first argument to the select, oh no, sorry, that's not the one, to the select 67.
Here.
Right. So you bind your Y features, and the options that you can select are given by the content of your features variable.
Yeah, so by convention, symbols in the elements are going to point back to fields of the reactive model. So then, yeah, if we want to pass the actual data, we can just pass in a string or a number or whatever we have. But in the cases where we see symbols, these are going to be references to the fields with the same name in the reactive model. So then the select will bind to the X feature, this one, and this will bind to the Y feature, and the options collection is going to take this this array, which corresponds to the feature field in the reactive model. And this one we can also see. Let's see. So these are defined in the select.jl file. No, this is not the right one, I think. That's from Genie. We need this one. I think, check. Stipple UI. Yeah. Yeah, so this one is going to take a symbol for the field name. It's going to take then additional arguments, and then it has the options. The options reference, which is also passed as a symbol, and then we can pass additional keyword arguments in order to customize the rendering and the options of the UI element. Is this okay? Makes sense?
Yeah.
All right. Cool. Okay, let me stop then this one. Stop REPL. And then, sorry.
Just one further question. Again, by Julian Vasil. How would you add styling to a widget? Let's say change the color of the slider.
Yeah. There are two ways of doing it. We can pass CSS attributes, for example, like we can pass styling to the elements as part of the keyword arguments. So because all of these UI elements are rendered as HTML elements on the web page, they accept any of the valid HTML attributes. So we can pass a style, or we can pass classes into the UI elements as additional keywords here. Yeah, so we can do class here, or we can do style, something like this. However, in order to keep things consistent, the approach that we want to promote is to work with themes. Themes are CSS files which apply to all of the elements, and they style consistently everything that is being rendered on the page. Stipple actually comes with support for themes right now, but there's only one theme, which is the default one, and which is called Blue, I think. So for example, if we look here, okay, I stopped this, never mind. Well, we can run it again, but yeah, the idea is that that the code that is being rendered on the page is already themed ready. It's just that the code comes with only one default theme, but we're planning on adding support for more themes in the future. For example, one request that came up on GitHub quite a few times was the ability to add a dark theme, and these things will be controllable from the configuration of the application. So we would be able to pass a theme, and that would be automatically bundled with the code, and it would apply the styling to all the elements consistently on the page. We're also hoping that once we're going to have version 1, we're going to have all the APIs stabilized and the documentation in place, people will start contributing themes and UI elements, and we will be able to create some sort of a repository where we would be able to install additional themes from like some sort of a Stipple store, and be able to customize our applications with different visuals and themes and elements.
Adrian, may I add one thing? I think you missed a very, very important part. All things that or the graphical elements that we have are quasi elements. So any keyword that you give can match the quasi component attribute. And for example, the slider has the attribute color. So if you would add color and then a value that is acceptable to JavaScript as a color, it would change the color.
Okay, yeah, that's
or
right.
You could, so that would be probably what you're looking for. Just add color equals, and then
can we do something like red?
Either, I don't know whether it accepts red. You can try it, perhaps.
I think I need to evolve the whole thing now here for this to work.
If not, you can give any hex color just in the JavaScript type of coloring, or you can give probably.
Oh yeah, it worked.
Yeah,
it already worked. Pretty cool. Yeah, that's awesome. I haven't tried this. This is really nice. Yeah. Okay, that works. Super cool.
And you can. So if you wonder how to style your elements, you can always go to the Quasar page, where every element is well documented, and all the attributes that live there in the Quasar element directly translate to the keywords here in Julia. There's one caveat, I'd say. There are many attributes that have a hyphen, a dash in the name, and this dash is normally translated with a double underscore in the Julia backend.
Yeah.
So yeah, you're right on the correct page, and there you see how many possibilities you have to style your code. And at the very bottom of this page, there's always a summary. Yeah, and you can look into the code.
Here, the style API.
Yeah, and here, this is the API that gives you a summary of all the possibilities of styling your
So then how we would
element.
Label color, we replace it like this.
Yep.
Label color equals, what color should we give it, like green? Oh,
yeah.
And we can do. Yeah. Nice. So yeah, then elements can be styled individually using all the API provided by Quasar. But yeah, I mean, my recommendation would be to for the overall styling of the page to just look at theming, and that's probably something that we should include in the documentation, like how to create themes and how to, yeah, probably by starting with the dark theme.
Yeah, you could add primary as the name for a color, and then it refers to the primary color of your theme.
Okay, yeah, here they are.
Exactly.
And if I remember correctly, Quasar also has color themes somewhere. So like here, where they have these name colors, so till 10. But yeah, color palettes, these ones. So these ones. So only,
yeah, they have primary, secondary, and so on, so on.
Yeah. An issue is going to be to harmonize the theming between Quasar and Apex Charts and Plotly. But that's one of the things that we want to do, just be able to apply one theme to all of the.
You can also enter the stipple palette colors. I think you have to add something like var in front. I have to look this up. I did this once already.
Would it apply to plots as well?
Yeah, I think so. Yeah.
Nice. Okay. Does this answer the question then? I think. Yeah.
Yeah, seems to have answered the question. Thanks
All right.
a lot.
Yeah, cool. Thank you. All right.
Cool. Okay, let me stop this. Boop. And then see the first step. I'm going to run it first. Maybe it's easier like this. Which is basically just the complete version of the data dashboard. The one we saw here, basically, but it's just running here. And while it loads, let's take a look at the code. So in the last part, then in the previous step, we have seen, let's say first step was about setting up the placeholders for our UI. We have put all the rows and all the contents, the element, the cells where we wanted to render our UI. And then in the next step, we introduced our data, and we outputted that on the front end, and we've seen how Stipple has already connected all the bindings, and we were able to get the data synchronized between backend and the front end. But as it was here, it didn't do anything. Nothing happened when we changed things in the UI, because we haven't set up our backend logic to react and execute code when updates are being sent from the front end. So then in the last step, we pretty much need to add the handlers. Yeah, Helmut has already demonstrated how to do the on bindings. Here I'm using a different one. I'm using the one called on any, which is triggered when any of these values are going to be changed. So in Helmut's example, we had on, which took one individual value being, or was listening to changes from a specific value. This handler is going to get triggered when any of these are going to be changed. So basically in our handler, we say that if the X feature, which is this, or the Y feature, or if the number of clusters, or if the number of iterations is going to change, then we want to run the plot data function on the species column. And we want to the result of the function, we want to update the reactive property iris plot data. And then we want to compute the clusters. And these are the functions. So plot data sets up the plotting data and outputs it, which is used in order to render the plot on the front end. And the compute clusters function uses the clustering package to run the clustering algorithms and to update the values. So the iris data, which is behind the data table at the bottom of the page, and the cluster plot data in order to re-render the clustering plot. So this one and this one, once the clustering is being run. Okay, it seems like our code has loaded. So now I have the page, which now, thanks to the handler, is interactive and listens to changes from the front end and computes data and pushes updates back onto the front end. So now if we go and choose some properties, and then we give it a bit of time, as is the first run. It's going to compute and plot our species cluster, our computed cluster, and then update the clustering column here. Okay, the first load is a bit, well, the first run is a bit slower because of, well, time to first plot. But we can see that, for example, now it's a lot faster. If we change the number of clusters, we can see how this is being updated on the fly. And yeah, if we do one, we can see that also the data in here as well. And well, clustering works quite well. But for example, the more iterations we run, in theory, the better is going to change. But yeah, the results of the clustering don't really, here it changed. So it looks like here between 40 and 50, clusters changed a bit. And of course, we can do some kind of exploratory analysis, and we can just look at clusters by pairing different features. Sepal length, sepal width, which does not identify any clear clusters. But maybe if we use sepal width with, I don't know, petal width, neither sepal length, petal length. So the best clusters are going to be petal length with petal width. Okay. Yeah, that's about it. Any questions so far, or any questions about this? I don't know.
I would have a nice remark here, because I always like this dashboard applications also for the Julia language itself. we've seen that it took some time on the very first plot, yeah. But this also shows kind of the feature of Julia, that it then delivers very fast recomputations.
Yeah.
And this is nice to see, so that nothing here is cached, but everything is recomputed again and again, which makes it very flexible dashboard. So you can do whatever you want and still have, by using Julia, the guarantee of using some optimized compiled version in the background.
Yeah, yeah. I mean, you can see, like when we change the number of clusters, it's basically instant. So the clusters are reprocessed, all the clustering algorithms they rerun again, and the data is being pushed over the wire into the front end, and everything is, well, the data that changes is being re-rendered, and is really, yeah, it's practically instant as well. The clusters here in the data table are being updated. So yeah, once the time to first plot is being addressed, things go much faster. Yeah, yeah, that was everything from me. I don't know. I hope it puts things into context and shows a bit of what can be done. This is still very much work in progress. So many of the things that you've seen today are like a few days old. But it's maturing as we're approaching to the level of features that we want to have. Of course, there's still more work on the various plugins themselves. For example, like we discussed, interacting with the plots and supporting all the I don't know, very particular APIs of all the plotting libraries. But the good advantage is that taking this modular approach, we're using independent packages for each of the features. We can get Stipple Core to version 1, and then we can keep working, hopefully, with the support of the community to also add more features to the other packages independently, and get those ones to version 1 as well. But I mean, the objective would be to get to a scenario where we can implement maybe 80% of the common functionalities in data dashboards with a lot of ease, and just have it well documented, and yeah, just covering all the necessary features.
One further question from my side.
Yeah.
This is having Julia in mind, that it can just in time compile arbitrary code functions, or I mean, this is kind of the basic building block of Julia. Can we also have flexible code compilation, like we have just a text field on the front end defining a function to aggregate some data, or to define a distance function for clustering, and just use this and compile this on the fly? Is there something like this possible?
I can answer that because I did it. It is, wait, I have an echo here from my second computer. I need to switch this off, sorry. But there's some risk to it, because you open the full capability of Julia. So if Julia compiles it, it can do any harmful code. So I allowed this option for administrators only currently, and I have something like a console, because everything runs on the server. And if I want to test whether it works or not, it's running currently on an Amazon. I can execute any code on the server that I like. It's easy to do. I could share this part of the code probably. We're using it to maintain our server. It is, as Stefan said, the first time we use it, it takes some time to compile the things. So we typically click all the important pages, or we have scripts that run the pages after restart of the server. But then everything is very quick, and all people who use it say, "Oh, it's incredibly fast. It works to China. It's so fast." And anyone who has worked with a Python dashboard says, "Ooh, you're fast." So it's possible, but you should really take care, make some security checks whether what you transmit is something that you want to have on your system.
So in a sense, we could even implement some sort of Julia REPL in the client side with auto completion and all these things. Probably there's JavaScript libraries for that, and it could just just pass code over to the backend and execute it there in the Julia instance. Hello.
Visit us.
That's really nice to hear. And so that's more kind of a question for sandboxing the server environment enough so that it's secure.
Yeah. Perhaps another comment, who has worked with Vue already knows that Vue has this kind of plugin system. They are called, I forgot it now. The plugins, Adrian, help me. They have system.
Or...
These plugins that you I wrote them. I forgot the name. And I would like to have these on the Julia side as well. So you write some component mix-ins. They're called mix-ins.
Okay.
And we could have these kinds of mix-ins on the Julia side in the very same way. And you just have always if you have the same piece of code, you can implement it in your Vue component. I have the idea of bringing this to life at some point.
Wow, that sounds amazing. Would it be Julia code or JavaScript?
Julia code? Yeah, that would be Julia code. Because currently we have these mix-ins on the JavaScript side, and I've used that to implement the reviver, also to implement a listener that can that allows changing variables without the triggering. That would be cool to have this on the Julia side as well.
Yeah, sounds amazing. Super cool. All right. Thank you, Julian, for the feedback and for joining us.
I hope you liked it. I hope you learned a bit how Stipple works. If you have any questions, you're always welcome to write in the issues of Stipple. We're trying to improve the product a bit over time. We help also in the comment section when we can. And we have particularly the Stipple demos, which is a living document. I put the code of today already in the GitHub. So you find the new API, I think it's called new API, a new Stipple API or something there in the GitHub repo of the Stipple demos. I'd like to share one screenshot just to make you aware of what you can do with Stipple. And I use my other computer. That's why I don't watch in your direction. So I do this. That's the wrong page. That's difficult to. I have this. Can you go away? This can't go away. I can't change the window because this is sitting here in front. Can I? Yeah. Right. Yeah, I have it.
Yeah, this looks
amazing.
So
this is my Monopoly game, and I can throw the dice. I can buy something, and if I buy it, I get the color of my things. These are icons that move. My son is a fan of Monopoly, and then I have to pay the rent. So I rent it, and all is automatically calculated. It's in German, of course. I'm not sure whether I'm allowed to share it because there are copyrights on the design and layout. So currently I have to clarify whether I can really share it on GitHub. I'd love to. So everything is built in Julia. It's pure Julia, and it's Stipple interface. And I did the coloring of icons just with as I told you just before, with coloring, just choose a color. But from time to time, I had to use CSS elements, but you can always add any CSS code that you want, just adding it to your user interface. Just make a multiply symbol and then your CSS code, or write a function that produces your CSS code and just append it to your UI, and you have it there. So it's really quick and dirty, if you like, and you add, and there's even this style, a function that adds this style, right? Adrian, you just enter style and you have it.
Yeah. Oh, this is really amazing. How did you make the head of the dog move a bit when the spider arrived there? Like,
it's automatic. It's just if you enter a transition, this is a CSS style.
Okay.
So you just enter the new coordinate of a thing. You have to. This is a style attribute. You have to calculate the coordinate, and I just put this coordinate in the style, and the rest, the animation is done automatically.
Nice. So do you,
by the CSS.
Do you watch for when you have two players on the same cell, or?
Yeah, I watch if I have two players on the same cell and then they move apart.
Nice. Do they always move in the same position, or do they move like randomly, or?
No, you're there randomly. Yeah.
No, I mean, how you position them on the same cell. It's like you have.
Oh no, just a circle. I put them on a circle, divided by the number of participants, and then.
Okay.
2 pi over a number of participants, you know.
Yeah, this is lovely and super smooth, like the animations work.
It shows really impressively how you can customize this whole dashboarding solution.
It's amazing. Yeah.
There are a couple of questions actually within the last minutes. I want to speak them out loud. So first was Pierre Springer, who asked whether you have any guidelines for contributions.
We don't have at this point. We're working on the documentation, and definitely there's going to be a section about developing plugins and how to do it and how to wrap them, and maybe set up some sort of API to make it easy to set up the boilerplate, let's say, for the Julia wrappers. So far, users have needed, for example, other components which were not part of the current implementation of Stipple UI, and then they added them for themselves and then committed the contributions. If you look at the source code, there's one module for each UI element. So if there's a mapping between Julia modules and UI elements, and it's code is quite simple there. And now we're making progress with commenting the APIs, so with doc comments, and pretty soon we're going to generate the documentation based on that. So at this point is really adding the needed modules, commenting with doc comments, and that's it. We're gonna have a section for people that want to contribute, but at this point is we're just trying to pretty much put everything out there and see what kind of use patterns and design patterns emerge, and see how we can organize things better.
I mean, you can always write a fork, do your fork, and write a rep PR, and we will comment on it. Either we write it or we just make some proposals how to modify. Adrian started always with only 2 indent. I think that's your style, right? The 2 indentation thing. And didn't you have a contribution guide for Genie? I think you wrote one. No, I remember having read some contribution guidelines by you. I think I read about the indent of 2.
There's a I think we should adopt officially one of the Julia ones. I think there's one called the Blue something from Invania. So I think there's a famous one which probably adopted by most of the community. So let me check.
Well, I try to adopt your style as much as I could, but I have also my personal style from time to time.
Yeah, we should come up with. I mean, yeah, it's called Blue Style.
Okay.
Actually, Blue Style is 4 spaces per indentation level. So yeah, if we adopt that, we can switch to that. So it's by Invenia, Blue Style. Quite extensive.
Currently, we're still quite flexible. We're happy about anybody who joins the community. I think it's still a path to go to make Stipple big, but I think it has the potential to be the counterpart of our Shiny also.
Yeah,
it's really fun to work with it. I had much fun to develop the Monopoly. That has been done for my son to make him interested in programming, and he also loves Monopoly. So I thought it would be nice to have this playable. And then buying houses and so on cannot be done currently by the API. So this is still manual process. So buying houses is something like Häuser kaufen. So this has all be done manually. So you first have to enter the street of where you are, and then 3 houses for Badstraße and for Turmstraße, for example. That would be the interface. Currently, you cannot buy it because you don't own it, and then gives some error. It's not yet streamlined, but it works for a nice game in the evening.
Yeah, it's lovely. Super nice.
Yeah. And I invented, I don't know who's familiar with offset arrays. Offset arrays are a way of using any index you like for Julia arrays. And sometimes it's really convenient because if you have JavaScript on one hand and you want to use all these fields, you would also like to have the same indexing on the Julia side. And you can do that with the package offset arrays. And I've added the possibility of using that as well. So if you use offset arrays here, they will have the index that you give them at the beginning. And if you only change elements in this array, or even if you attribute a new array, it will keep the old offset index. So indices on both front end and back end can be the same. Yeah.
So you're using zero
based for the streets, for example. 0 is the lowest, and then just in order to have the easy counting 1, 2, 3 from Badstraße to Schlossallee.
There's another question from Gregor already, also a bit back. Would it be possible to deliver dynamic Franklin projects?
What are Franklin projects?
Good question.
Static for Julia, Franklin, but yeah, I don't know. Can you give us more details, like dynamic Franklin project? Okay.
Static site generator.
Yeah, I can talk a little bit about Franklin. It's a static site generator, like you said, a little bit like Jekyll or Hugo, but has nice LaTeX formatting already in there and code execution, obviously. And I use it to build my personal website with static computations, which is quite nice. But adding a dynamic component would be cool.
Yeah. So would you like to run, to run the computations on the server side when the users interact with it? Because one of the yeah, go ahead, please.
Sorry, yeah. I mean, on one hand, currently I'm serving them statically, but since I'm having done a lot of work with Franklin and the write-up is quite nice, it's like Markdown. Obviously, I could use Genie when I'm going dynamic. Obviously, that would probably. I mean, you can include it in Genie, probably, right?
Include Franklin or?
No, Stipple and Genie.
Yeah. I mean, Stipple runs
That's
on top
trivial.
of
Yeah. So, but
Stipple runs on
but then
Genie.
Yeah.
So basically the question just is if we could plug the markdown, the reading of the markdown into Genie to generate the Genie pages for it. With probably a certain markup for this is Stipple.
You can probably even use Franklin in Genie. I never tried, but if Franklin has like this kind of parser,
it has.
You can load it into a Genie app and use the parser to generate the pages and then serve them through Genie. But of course, it would be the issue that it would run dynamically on the server, so you would need to host it somewhere.
Sure. But since that's so fast and nice, that's exactly a good way to make it to run it on my server.
However, one of the things that I would really like to implement at some point, and ideally quite soon, would be this this ability to include Stipple, either whole Stipple, dashboards or part of a dashboard, or sub dashboards, in the same way that you can include, for example, a GitHub. What's it called? The GitHub. Or I don't remember, gist, right? When you can include like a live piece of code or some sort of live JavaScript rendering on a page, which is being served by another by another service. So I think it would be really nice if we could have this kind of web component which references and renders a part of a Stipple data dashboard, which is hosted on the server. So you can maybe, like we have this full page data dashboard of Iris clustering, but we just want to include the slider for the number of clusters and the clustering plot. Would be able to expose that and include it in a sort of a widget. So that'd be one thing, and then there would be the possibility to include this dynamic feature into a Franklin static page. So that would be one way to go around it. And another interesting possibility, which is theoretical, but it seems quite interesting, is that there is this option of pretty much dumping all your data, if you don't have a lot, into JavaScript, so into the view model. Like, for example, was the case with the data behind the data table of Iris data. And then, in theory, if you disconnect the backend, once all your reactive front end is being set up, and you have all the data available on the front end, you can just disconnect the backend and the front end will keep working. So what happens is that it's going to fail the updates back to the backend, but the front end will still function if all the data is there. So in a sense, we can render JavaScript applications from Stipple, and we wouldn't need, if you don't need to update anything, they would just run independently. So that's also something that that could be done. Of course,
and if you make the variables read only, they will even not try to push back. Yeah,
exactly. So that can be done. You can render an interactive data dashboard or interactive part of the UI that creates the JavaScript which just works and responds to interactions just on the front end.
Okay,
you could open an issue. You could open an issue on Stipple and perhaps put a link on Franklin and make up a small demo page of your Franklin project that you have in mind. And then we could come up, I think we could do something similar as the markup plugin for Stipple, where you just have something where you write your Franklin code in and then it gives you full frame and renders that. It should be possible with Stipple.
I will play around a bit and I will open the issue and then I will discuss in that.
Yeah.
I have some idea. Well, I have some stuff laying around here that I need to reactivate, where I had a complicated back and forth with Elm actually on the JavaScript side. Maybe I need to see if I can use that. That's kind of a Haskell JavaScript compiled thingy. I don't know. Otherwise, yeah. Okay, thank you. Thank you. It looks really great and promising. Looks fun to work with. And the monopoly is great. Thanks.
Thanks.
That made, yeah.
Great. Thanks again from my side. There's actually one last question from the 3 question set. And the last one is from Daniel Heger. He is asking, how would you integrate user authorization with Julia and Stipple?
Okay. Yeah, that's so authorization. Are we thinking like authentication, or is it also more than authentication is basically authorizing access to different parts of the page? Or, well, anyway, I think this is something to be considered on the server side. And it so happens that I recently had some discussions with somebody working on the Julia project about this. So authentication we already have, because Stipple runs on top of Genie, as mentioned in the intro. We can access the whole package ecosystem going down, and Genie has an authentication, a database-backed authentication plugin, where we can, it uses a database backend, and we can register there our users, and we can place functionality behind an authentication requirement. So if the user is not authenticated, the Genie plugin will just redirect the user to a login page. And that takes care of authentication, which basically means knowing that the user is identified on the platform. So it's a user that we know, that has an account, and we know who that person is. So that's being done on the server side, and pretty much in the case of the Stipple dashboard, if the dashboard requires authentication, a user that is not authenticated will not be able to access the page at all. So nothing gets rendered. Instead, it's being automatically redirected to the login page or the sign up registration page if one like that is being offered. And then the issue of authorization. If the user has successfully authenticated, the next plan in this discussion was to create an additional plugin for Genie for authorization, which would use access control lists and role-based authentication, role-based authorization. So it's basically a new plugin which would allow to assign a role to an authorized user, and its specific role would have abilities. And then in our code, again, on the server side, we will be able to say that, if the currently logged in user, authenticated user, has the, list payments ability, because it has the role as admin or whatever, or financial officer or something like that, then it would get access, and that part of the user interface would be rendered. So these checks would be done on the server side, and the code which is placed behind authentication and behind authorization would not be executed if the user would not have the necessary privileges. We haven't, this is new, so we haven't gone into really advanced use cases. But yeah, this is the basis. Then we'd have to see how, for example, a reactive model would be structured in for example, to support role-based authorization. So to have certain values which are maybe available to a certain role, that can be more trickier, and it's hard to mentally see all the details. But that's that's the big picture, at least. And The next step would be to create this role-based authorization plugin, and also make it available as open source.
Adrian, may I add on this? Perhaps people don't have in mind what can be done already quite easily. I share my screen again. I hope you can see it. Up to now, we had always talked about very simple things, but if you have your root command, you can you have the params macro that gets you quite some information of your call or the incoming request, and also the get headers. You can get quite some interesting information out of that. And here in the code that I have uploaded to GitHub, meanwhile, on Stipple demos, you have this tiny little piece of code, and I save the information that you can get out of it in the global variables last params and last headers. Have a look on what they spit out. For example, you can get the information that is always transmitted as user agent. And if you would split this out and just define this as a new model, and you don't only initialize one single model, but you have a models dictionary like this, and this is then from any to your, this is my example type. Then you can ask, does this user already exist in my dictionary? Or in my models dictionary? If it does exist, you say, okay, using existing model, otherwise create the new, so initialize a new model and set the directory entry according to it, and then call the user interface with that specific model. Because until now, we always had user interface and was only a function and used the variable model that was globally defined. But this is not necessary. You can also define your user interface containing the variable model here. And then everywhere where you have model defined in your user interface, it will use the model that you defined, or that you passed. Yeah. So going back to the piece of code that I had, the routing command would not call the user interface alone, but always with a correct user. So if you have any function deriving your user, or you can also use any other, just a small Apache in front and then forward it. So just have a Julia page. Then you have perhaps already identified your user. Then you create a model for each user. So that would be the way forward. Perhaps that gives some more.
Yeah, I guess it's a great point. So if I may rephrase, basically the reactive model in a sense is the state of the application. So in our example so far, we used one state. But if we work with multiple users, then each user can have its own model, so its own state of the application. And then, one way to approach this is, for example, if in the model we have a list of, I don't know, let's say payments, if each user has its own model, so its own state, for a user which is not authorized to look at payments, the list of payments, so the variable corresponding to the array of payments, will always be empty. And the handlers will simply never populate, never retrieve the list of payments from the database or from wherever it's stored. And for it would just check for authorization and simply leave the list of payments empty for that respective user who does not have access to it. While if it's if it's a user with financial abilities which has the access to this kind of information, then our code will retrieve the list of payments from the database, populate the variable, the list of payments, and display it on the user interface. So I think this is a great approach. Yeah, exactly.
Thanks a lot also for the question. One question which came to my mind and fits pretty well here. Can you serialize the Stipple models so that you may store them in a database just all at once?
I think that's possible. I mean, I haven't tried it, but well, maybe we could use Julia serialization, and that might work out of the box. If not, we can probably use a custom serializer, because if you think about it, all the reactive values inside the model are already serialized into JavaScript values, as into JavaScript dictionaries, and then we can also construct them back. So yeah, there's definitely a way we can store them as JSON and then reconstruct them back through a custom serializer. But I would expect that Julia's serialization would just work out of the box.
Thanks, makes a lot of sense, yes.
You're welcome.
Okay, great. So there haven't been any further questions, and we've also been on some time for now. I think it's good time to wrap it up.
Yeah.
There's one further thing coming in from Pierre Springer. Just maybe quick. So currently all users share the backend by default. So if one user changes the site, it gets updated for all users.
Right.
Yeah, but that's something that's going to change hopefully in a week or so. It's how the prototype started, and then we realized that I mean, now you have to take the approach that yeah, Helmut just demonstrated to basically create your own instance. We want to switch it so that by default each user is going to get its own state, because in general this model of shared state is not what most people would expect. So yeah, right now there's by default one state. So when somebody updates the state, everybody sees the update. But we're moving to a different model where by default each user has its own state. So if there is a case to want to have the shared model, that would have to be explicitly opt-in.
Great, seems to have answered the question.
All right. Thank you so much. It was really fun and yeah, very pleasant chat.
So then thank you also from my side again, Adrian and Helmut, for being here today, giving us the insights into Stipple. There was a lot of details and a lot of nice pictures as well. So I think for me, it was really great mix to get into the depth and also see the power it has. Like, if you just look at it, that's really nice that you have this Julia and JavaScript interaction working that well already, and looking forward to seeing it growing bigger and bigger. The potential is there.
Thank you so much for hosting us and for all the
thank you, Stefan.
I'm glad. And also thank all of you who joined today. We are still 17. That's pretty big group.
So we had almost 50 in between.
Yeah, it's really amazing. Thank you for joining today and being here until the end and getting all these deep insights with you.
Yeah, it was fun.
Thank you. Bye-bye. Good evening. Good night.
Bye-bye. A good time.